Hi everyone, welcome to WinPoint online classes. Today we are going to discuss some of the important topics from the chapter Carbon and its compound. Please subscribe to this channel, then you will get instant notification of revision classes, live classes and sample paper solutions. Today we are going to cover properties of ethanol, properties of ethanoic acid. These two topics are very important in the exam point of view. Properties of ethanol. First we need to know the formula of ethanol. What is the formula of ethanol? Ethanol means there are two carbon atoms, right? So that is ethanol, two carbon atoms and one hydroxyl group, that is ethanol. So first we can discuss the formula of ethanol. It is the formula of ethanol. Here you can see that CH3 CH2 OH. This is the formula of ethanol. How many carbons are here? 1, 2. There are two carbon atoms and 6 hydrogen, 1 oxygen. So C2H6O. That is the formula of ethanol. You need to know how to write the formula. You need to count the number of atoms. How many carbons are there? How many hydrogen atoms are there? How many oxygen atoms are there? Then just write it. That is a formula. That is a chemical formula. Now we can discuss the physical properties of ethanol like melting point, boiling point. What is melting point? Melting point is the temperature at which a solid is converting into liquid. Melting point and freezing point both are same. For example, in the case of ice. What is the freezing point of water? 0 degrees Celsius. In 0 degree, the water is going to convert into solid, ice cubes. And melting point of ice is also 0 degrees Celsius. Melting point and freezing point both are same. Here we are going to discuss some of the physical properties. It is an active ingredient of all alcoholic drinks. Ethanol is used in alcoholic drinks. It is an active ingredient. Next one, it is a good solvent. Solvent means if you are adding something, it will dissolve in it. That is solvent. Water is universal solvent. If you are adding something into water, most of the solid will dissolve in water. So it is an universal solvent. Ethanol is also good solvent, so it is used in medicines. Next point, boiling point of ethanol is 351 Kelvin. At 351 Kelvin, ethanol, it is liquid state, right? It is in liquid state. When the temperature is increased to 351 Kelvin, it will convert into vapor. That is the meaning of boiling point. The boiling point of ethanol is 351 Kelvin. Melting point of ethanol is 156 Kelvin. Melting point or freezing point. At 156 Kelvin, liquid ethanol will convert into solid. That is the meaning of this statement. Next one. Now we are coming to the important topics. Reaction of ethanol with sodium. These reactions are very important. Okay, reaction of ethanol with sodium. Sodium is highly reactive. We are keeping sodium in kerosene oil, right? Because it will react with air as well as water. Okay, so we are going to discuss the reaction of sodium with ethanol. First we can write the equation. Ethanol means CH3 CH2OH. Here you can see that it is CH3 CH2OH. Okay, here there is a 2. It's a balanced equation. I am going to write the balanced equation. You need to learn the balanced equation. So it is CH3 CH2OH ethanol plus 2Na, reaction of ethanol with sodium. What is happening here? What is going to happen here? Here there is an exchanging process. The sodium will replace hydrogen from the ethanol. It's a replacement. So here you can see that the reaction will be like this. Just exchange it. Then product will be CH3CH2ONA. Here you can see that CH3CH2ONA plus 2 hydrogen H2. These are the products. Let's write the equation. It is the product here 2CH3CH2ONA plus H2. Okay, so sodium will replace hydrogen from ethanol. Then we will get sodium ethoxide and hydrogen. Let's write the equation now. 2CH3 CH2OH plus 2Na. What is happening here? Here they are exchanging these atoms. Sodium is replacing hydrogen from ethanol, right? So here this is the reaction. They are exchanging their positions. We are getting CH3 CH2ONA plus H2. You need to learn the balanced equation. Just learn this, the reactant side, then exchange it, you will get the product side. Okay, so we are getting sodium ethoxide. Ethanol is reacting with sodium to produce sodium ethoxide and hydrogen gas. Next reaction. Reaction of ethanol with sulfuric acid. This reaction is also very important. Sulfuric acid is H2SO4. It is CH3CH2OH. I am writing this C in expanded form to understand the reaction. It is CH3CH2OH, ethanol. Okay, the reaction is taking place in the presence of sulfuric acid. Here I am writing concentrated sulfuric acid. This concentrated sulfuric acid is a dehydrating agent. Dehydrating agent means it will take water. It will take water from the compound. If you are adding sulfuric acid, it will take water. Here can you see water here? There is an OH and there is an H. So OH plus H is H2O, right? OH plus H is H2O. So here the reaction is like this. The sulfuric acid is going to absorb H2O from this ethanol. H2SO4 is going to take one OH and one hydrogen, that is H2O. So what will be the product here? It will be CH2 double bond CH2, right? If we are removing one hydrogen and one OH from this compound, it will be CH2 and CH2. CH2 and CH2 means in between this carbon it will be double bond. CH2 double bond CH2 plus H2O. This reaction is known as dehydration reaction because sulfuric acid is a dehydrating agent. It will absorb water from this compound. Now let's write the equation. CH3CH2OH gives, in the presence of concentrated sulfuric acid, we are getting CH2 double bond CH2 plus H2O. This is the reaction. This reaction is known as dehydration. Complete the reaction, identify the reagent, write the name of the product, write the name of the reactant, how we can make ethene. There are a lot of questions from this session. Okay. Heating of ethanol in the presence of excessive amount of sulfuric acid gives ethene. This reaction is known as dehydration. Sulfuric acid is dehydrating agent. Concentrated sulfuric acid is dehydrating agent. And this is the reaction. Next one. Properties of ethanoic acid. Ethanoic acid is CH3COOH, carboxylic acid, right? Ethanoic acid, carboxylic acid. First we can discuss the physical properties, then we can discuss the reactions. The formula of ethanoic acid is CH3COOH, 2 carbon and there is a carboxylic group, so it will be ethanoic acid. Common name is acetic acid. Ethanoic acid is IUPAC name, International Union of Pure and Applied Chemistry. It is IUPAC name. Its common name is acetic acid. What is the use of this acetic acid? First we can discuss melting point and boiling point. The boiling point of ethanoic acid is 391 Kelvin. At 391 Kelvin, it will convert into vapor. Okay. Melting point of pure ethanoic acid is 290 Kelvin. 290 Kelvin means it is 17 degrees Celsius. Just subtract 273. You can convert Kelvin to degrees Celsius. For converting you can subtract 273 from this number. 290 minus 273, 17 degrees Celsius. What is our atmospheric temperature? 27 degrees Celsius, sometimes 40 degrees Celsius. Okay, 17 degrees Celsius is too cold. Okay, melting point of pure ethanoic acid is 290 Kelvin. What is the meaning of this statement? Melting point and freezing point both are same, right? At 290 Kelvin, ethanoic acid will convert into solid. That is the meaning of this statement. Freezing point and melting point both are same. At 290 Kelvin, ethanoic acid, it is in liquid state, it will convert into solid at 290 Kelvin because its freezing point is 290 Kelvin. Okay. Carboxylic acids are weak acids. It's a question. It's a very important question. Ethanoic acid is known as glacial acid. Why? What is the melting point of ethanoic acid? It is 390 Kelvin. It's very important. The melting point of the freezing point of ethanoic acid is 390 Kelvin. Okay. Here, this is ethanoic acid. It is in liquid state, right? You can see that it is in liquid state. Ethanoic acid is in liquid state at normal temperature. Just imagine it is winter season. Okay, if it is winter season, what would be the temperature? Maybe 3 degrees Celsius, 5 degrees Celsius, 17 degrees Celsius or 390 Kelvin. It is the freezing point or melting point of ethanoic acid. If the temperature is below 390 Kelvin, if the temperature is below 390 Kelvin or if the temperature is equal to 390 Kelvin, what is going to happen for this acetic acid? It will convert into solid form. It freezes, right? Here you can see that now it is frozen acetic acid, right? Because of this cold climate. Because of this property, Acetic acid is known as glacial acid. Melting point of ethanoic acid is 290 Kelvin or 17 degrees Celsius. During winter season, the temperature lowers below the melting point or freezing point and ethanoic acid freezes. This is the reason for this name. Ethanoic acid is also known as glacial acid. Next one, vinegar. We all are familiar with vinegar. In pickles, we are adding vinegar. Here you can see the bottles of vinegar. Okay, it's fruit vinegar. Vinegar is dilute form of acetic acid. If you are adding water into acetic acid, we are going to get vinegar. 5 to 8% of acetic acid, which means if you are taking water, 95% of water and 5% of acetic acid, very diluted one, extremely diluted one, right? We are taking 95% of water and 5% of acetic acid. That is called vinegar. 5 to 8% of acetic acid in water. Okay, so take some acetic acid, add water, we can make vinegar. 5 to 8% solution of acetic acid in water is called vinegar. It is used widely as a preservative in pickles. We need to keep pickles for a long time, so we are using preservatives. Next one, reaction of ethanoic acid with ethanol. First we are taking ethanoic acid, it is CH3COOH ethanoic acid plus CH3CH2OH ethanol. You have to know how to write the formula. You have to know the method. If you don't know the method, check our previous video. Okay, you can go through the video and you can watch the video again. CH3COOH plus CH3CH2OH ethanoic acid plus ethanol in the presence of sulfuric acid. Okay, if there is a reaction between ethanoic acid and ethanol, OH from ethanol and hydrogen from ethanoic acid, they are going to combine each other. OH from ethanol, OH, right, and hydrogen from ethanoic acid, H, OH plus H, it is H2O, right? Here the reaction will be like this, OH plus H, H2O in the presence of sulfuric acid. Okay, so the remaining part you can combine. So what will be the product? CH3COO CH2CH3 plus H2O. This compound is known as ester. Here you can see that this compound is ester. This reaction is known as esterification reaction. Sweet smelling substances. Esters are sweet smelling substances. We are using esters in perfumes and other flavors. Okay. Esters are sweet smelling substances. These are used to make perfumes and flavouring substances. Esterification reaction. If there is a reaction between ethanol and ethanoic acid, we are getting esters. Generally, we can say that if there is a reaction between alcohol and carboxylic acid, we will get ester. This reaction is known as esterification reaction. Carboxylic acid is reacting with alcohol in the presence of sulfuric acid to form sweet smelling substances known as esters. This reaction is known as esterification reaction. Saponification. Now we got an ester, right? CH3COO CH2CH3. We are going to add sodium hydroxide into that. We are adding sodium hydroxide. So here we are taking that ester CH3COO CH2CH3 gives NaOH. Okay. This is ester and this is NaOH. What is going to happen in this reaction? Just opposite of esterification. Okay. Here the bond will break from here. Here the bond will break and Na from this sodium hydroxide, Na will combine with CH3COO, OH will combine with CH3CH2. So what will be the product? CH3COONA plus CH3CH2OH. It's very easy, right? You need to know the technique. Just break it from here and add NaOH separately. This reaction is known as saponification reaction. Saponification. If esters are reacting with sodium hydroxide, esters will convert back to alcohol and sodium salt of carboxylic acid. This reaction is known as saponification because it is used in the preparation of soap. This reaction, we are using this reaction in the preparation of soap. So this reaction is known as saponification reaction. Next one, reaction of ethanoic acid with sodium hydroxide. Ethanoic acid is its acid. Sodium hydroxide is a base. Acid and base, it will be neutralization reaction. Let's check it. CH3COOH plus NaOH. What is going to happen here? there will be production of CH3COONA, because CH3COOH and NaOH, there will be CH3COONA. Reaction will be like this: OH from this NaOH and H from this ethanoic acid. So it will be CH3COONA plus H2O. We are getting sodium salt of ethanoic acid, sodium ethanoate. Here it is sodium ethanoate. We are getting sodium ethanoate and H2O. Reaction of ethanoic acid with carbonate and bicarbonate. We are going to discuss the reaction of ethanoic acid with sodium bicarbonate and sodium carbonate. There are two compounds, sodium carbonate and sodium bicarbonate. We are going to discuss the reaction of ethanoic acid with sodium carbonate and sodium bicarbonate. CH3COOH plus Na2CO3. CH3COOH, NaHCO3. It is sodium bicarbonate. The first one is sodium carbonate, the second one is sodium bicarbonate. Sodium bicarbonate or sodium hydrogen carbonate gives. Can you predict the products here? Very easy. Okay, there are CH3COOH and Na2CO3. CH3COOH and Na. So it will be CH3COONA. In both reaction there will be CH3COONA, CH3COONA. Right? Because sodium is there, ethanoic acid is there, then there will be CH3COONA, sodium ethanoate. Now, other products. You need to predict other products here. Na2CO3. So there will be carbon dioxide. Here also NaHCO3, carbon dioxide. So we can write CO2, and here also CO2, and here also CO2. Now, other product. There are lot of hydrogen, lot of oxygen. So H2O must be there. So the last product is H2O and H2O. After that you need to balance this equation. Second equation is already balanced. First equation is not balanced, so we can balance it. I think you know how to balance the equation. If you don't know to balance the equation, go through our video. We already made a lot of videos about balancing. You can go through that and learn balancing, then balance the equations. Thanks for watching.